These are the video notes for Objective 2B, Solving Exponential Equations. At the top of the notes, you have a reference to the properties of exponents that we will be using as we solve these equations. This is old material, review material, and I will link to related Khan Academy videos for you to use to practice if you don't remember your exponent properties. The first example in the notes is solving an exponential function, and we kind of want to increase our layers and our difficulty. So number one, we have 3 to the n plus 2 power equals 3 to the 3n power. And when you're dealing with an exponential equation, if the base of the exponent is the same, then the exponents must be equal. So here we have 2 base 3's, which means our exponents have to be equal, and we can just solve the equation in the exponents. So the answer to the first example is 1, and if you plug it back in, you get 3 to the 3rd power equals 3 to the 3rd power, which is a true equality, and therefore the solution checks out. Example 2 takes this problem and adds a little twist to it, and this twist is part of the properties of exponents and just understanding what to do with exponential expressions. So we have 9 to the m minus 3 equals 81 to the 3m. And in this problem, what we're dealing with is 2 bases that are not the same. So since these are not equal, the exponents cannot be set equal. However, we can change the base of the exponents so that they are equal, because 81 is a power of 9. In fact, 81 is equal to 9 squared. That means in the equation, we can substitute the 81 with its equivalent 9 squared. When we substitute it, we want to use parentheses. So we're going to write 9 squared in parentheses to the 3m power. This is our first use of an exponent property. We have 9 to the power of 2 to the power of 3m, and this is called the power property, or power to a power, in which case we're going to multiply these exponents. So what we really have is 9 to the 6m equals 9 to the m minus 3. The bases are the same, so the exponents must be equal. Final answer is that m is equal to negative 3 over 5. You should always check your answers, so it would benefit you to take a calculator and plug negative 3/5 in here, negative 3/5 in here, type this entire expression in your calculator, type this entire expression in your calculator, and make sure that you actually get the same answer both times. The next example is a fraction, and we've been talking a lot about exponential decay and what that fraction means in terms of graphing, and so we're going to apply that knowledge here. So we see the 1/4, and we know that 1/4 is equal to 4 to the negative 1 power. It's a reciprocal. So we can replace this expression with 4 to the negative exponent, or 4 to the negative 2x, and it would be equivalent. On the other side, we have a 16. Is there a way to make 16 the same base as a 4? Well, 16 is 4 squared. Using the power rule, we have 4 to the negative 2x is equal to 4 squared. Exponents or bases are the same, so the exponents must be equal. X is equal to negative 1. Plug it in here, type this side of the equation into your calculator. Does this equal 16? Alright, last example in this section of the notes before we increase the difficulty or the complication of our equations. 36 to the k minus 3 is equal to 216. So I happen to know off the top of my head that 36 is 6 squared. And I'm hoping that 216 is also a power of 6. So let's try 6 cubed. 6 cubed is 216. But if it wasn't, I could also try 6 to the 4th, 6 to the 5th, etc. If you can't find a same base, there is still a way to solve the exponential equation, and we'll get into that in the next part of this video notes. But for now, we're just practicing equations where creating a same base is possible. We're not talking about what if you can't make a same base, because that's actually where logarithms come into play with solving exponential equations. For this one, let's replace the 36 with 6 squared. And let's replace the 216 with 6 cubed. Apply the power rule. 6 with this one. Be careful, because we need to multiply this exponent by this exponent. And this exponent is a binomial. So as we multiply it, we need to make sure that we distribute. This is 6 to the 2k minus 6 equals 6 cubed. Bases are the same, exponents must be equal. 2k equals 9, k equals 9 over 2, or 4.5 would both be the correct solution. Now we want to take a look at same base equations that apply more of the properties of exponents. So these expressions are a little bit longer, require more steps of simplification before we can solve. So we're going to take a look at 3 squared times 81 to the 3n equals 243 to the negative n. So an exponential equation with multiple factors. The fact that these are being multiplied make this a factor and this a factor. These factors need to be condensed or combined before we can solve the exponential equation. Now I see a 3, that's its own base, which means I need to be able to make 81 a base 3 number and 243 a base 3 number. So off to the side, 3 squared is 9, 3 cubed is 27, 3 to the 4th is 81, and 3 to the 5th is 243. We're going to leave our 3 squared, times 81 is 3 to the 4th, equals 243 is 3 to the 5th, and then don't forget that negative n on the side. These are the power rule. With PEMDAS, we want to do our parentheses first. So we have 3 squared times 3 to the 12n equals 3 to the negative 5n. Now this is going to distinguish a highly proficient student from a proficient student, because from here we need to combine these, and if you go back to the front of your notes, you'll see the product rule. X to the a times x to the b is equal to x to the a plus b. When the bases are the same, we keep the base number and add the exponents together. So in this example, 3 squared times 3 to the 12n is 3 to the 2 plus 12n, and it's still equal to the 3 to the negative 5n. When the bases are the same, the exponents are equal, and we can solve this equation in 2 steps. Let's try that one more time with our last same base equation, and that's going to conclude part 1 of the video notes for solving exponential equations. Our last one has 5 to the 2x plus 3 times 1/5 to the x equals 5 cubed. So the base number is 5. Let's rewrite our 1/5 as its equivalent negative exponent. Then we're going to add the exponents according to the product rule. So 2x plus 3 combined with a negative x is going to leave me with 1x plus 3. And we're going to set it equal to each other. X plus 3 equals 3, x equals 0. This concludes part 1 of the video notes for solving exponential equations. In this portion, we only focused on equations where it was possible to find the same common base. In the next part of the video notes, we're going to talk about how a logarithm can help us solve an equation where the bases can't be the same.